All right, so let's look at momentum first. Momentum is mass times velocity. So for number 4, it's pretty easy. It's just the masses times the velocity, giving us 52.8 and 105.6 kilograms meters per second. For number 5, it's an inelastic collision because they're stuck together. Now the total momentum before the collision is equal to the total momentum after the collision. So you start from this point and you simply put in the numbers that are given in the problem and solve for your unknown variable. So for rail car A, it's 12,000 times 3. Rail car B, it's 8,000 times minus 2. This is the point where you have to be really careful, because the two railroad cars are traveling in opposite directions. One's traveling to the right and the other's to the left. So their momentums are going to partially cancel out, which means you have to make one of the velocities negative. It doesn't matter which one you make negative. You'll come out with the same answer, but you have to make one of them negative. And then for the other side, after the collision, you know the masses, you can put the masses in. V prime is the unknown velocity. So for the next step of algebra, you can just combine these, 12,000 plus 8,000 into 20,000 V prime. For these, it's just simple math. 12,000 times 3, 8,000 times negative 2, giving you that. Combine those, 36 minus 16 is 20, or 20,000. So we have 20,000 is equal to 20,000 V prime. Divide both sides by 20,000, you get 1 meter per second. Let's look at another problem real quick. We have a railroad car, one's very small cars, well, maybe carts, traveling. One is traveling at 10 meters per second. The other one is stationary. After they collide, they're stuck together. And again, we're solving for that V prime. So we can just do the plug and chug. Total momentum before is equal to the total momentum after. So the individual momentums is equal to the individual momentums. 100 times 10 plus 200 times 0. Notice I left the units in here just so that you can see how the units end up canceling out. The kilograms cancel out, leaving just meters per second behind. 100 V prime plus 200 V prime. Combine those into 300 V prime. So you do the math, you have 300 kilograms times V prime is equal to 1,000 kilograms meters per second plus 0. How do we get V prime by itself? We're going to divide both sides by 300. That turns this into 1, and 1 times V prime is just V prime. Over here, we end up canceling out the kilograms. 1,000 divided by 300 is 3.3. And I just rearrange the equation. We have V prime is equal to 3.3 meters per second. And that's it.